All right, the purpose of this video is to integrate what you know about Locus together with what you know about writing equations in the coordinate plane, and use these two ideas together to solve problems that involve both. As you watch this video, remember, keep in the back of your mind the purpose in watching is to learn. And if there's something that doesn't make sense, take a minute, rewind, replay the video until it makes sense in your brain. All right, without any further ado, I'm going to jump right into number 1. It says, when you make a call on a cell phone, the tower receives the call. The following information models the position and range of towers A, B, and that should say C. The question wants to know, are there any points where you could be within all 3 tower ranges at the same time? All right, so in looking at this problem, I'm going to approach this in 3 separate parts: Tower A, Tower B, Tower C. If I look at the equation that's been written for Tower A, I notice that it's in the form of a circle. And you should be able to recognize that as the equation of a circle in the coordinate plane. And when we deal with circles, there's really 2 things that we need to focus in on and pay attention. We need to know where the center is and what the length of the radius is. So the center of this particular circle is going to have coordinates 16, 10. His radius, well, if the square of the radius is equal to 100, then the length of the radius must be equal to 10. Tower B, they're a little bit more straightforward, and they come right out and tell us that this guy is a circle. They tell us that the center has coordinates 420, and that the length of the radius is also equal to 10. And then the last one, Tower C, again, you have to be savvy enough to recognize that this equation is that of a circle. And again, when we're dealing with circles, we really want to focus in on 2 things: the center, which in this case is at the origin with coordinate 0, 0. And then the square of the radius of this circle is going to be equal to 196. So the radius itself is going to be equal to the square root of 196, or in other words, 14. So now that we know a little bit more about these circles, we're going to go ahead and put them on the coordinate axes so we can take a look at exactly what's going on in this problem. Because these are rather large coordinates, I'm going to let each grid on my graph represent 2 units. So I'm going to go ahead and label my x-axis and my y-axis to indicate a scale. And then I'm going to get down to business, and let's get these cell phone towers on our graph. So Tower A has coordinates 16, 10. So there's his center, and the radius is 10. Now, in order to draw the most precise graph possible, I'm going to go ahead and grab my compass. You should at home, too, also grab your compass. So that enclosed inside that purple circle is all of the area encompassed by cell phone Tower A. The next tower I want to graph is Tower B. His center has coordinates 420, so I'm going to go put that on my graph. And this one also has a radius of 10. So again, I'm going to grab my compass so that I can draw the most exact graph possible, and I want that fellow to be blue just to kind of keep track of these. And this one I'm going to label B. And then the last one, Tower C, has its center at the origin, 0, 0, with a radius of 14. So there is Tower C. So in answer to the question, they want to know, are there any points where you could be within all 3 cell phone tower ranges? Well, in other words, what they're asking, are there any points on that graph that are in the purple circle and in the blue circle and at the same time also in the red circle. So if I go look at the picture, that little smidge in there that I just highlighted yellow represents the area that is both inside the purple circle and inside the blue circle and inside the red circle. So to answer their question, the answer is yes. And in my graph, that area is shaded yellow. All right, at this point, if you have any questions about that first example, go ahead and jot them down in the margin now so that you'll remember to ask me the next time that you come back to class. And I'm going to go ahead and head on to number 2. Number 2 says a city is going to build a new park. This park that they're going to build is going to be equidistant from a school at point A with coordinates 3, 3, and a school at point B with coordinates 3, -5. The park must also be exactly 5 miles from the center of town, which is located at the origin. Each unit on the graph represents 1 mile. Part A says sketch the compound loci on the graph, label with an X all possible locations of the new park. Part B, I'm going to worry about later after I've taken care of Part A. All right, so when tackling this problem, the first things I'm going to do is I'm going to go ahead and plot School A and School B on my coordinate axes. So there's School A. There's School B. And according to the information that was given to me in the problem, they've told us that this park has to be equidistant from each of these 2 schools. So I'm going to go find some points on the graph that are equidistant from each of those 2 schools. So this point here, equidistant. There's one that's equidistant. There's one that's equidistant. There's one that's equidistant. There's one that's equidistant. And I'm starting to notice that these are beginning to take the shape of a line. So now I know what that locus is going to look like. I can go ahead and sketch it in there. If you wanted to be fancy, you could say that locus is the perpendicular bisector of segment AB. All right, so that's the first condition that needs to be met. The second criteria that we're trying to meet here is that this park must also at the same time be exactly 5 miles from the center of town. So I'm going to go ahead and put my center of town at the origin. And again, I want to sketch all the places that are 5 units from that center of town. So I'm going to go ahead and grab my compass again so that I can be as precise as possible. Precision is important here. So anybody on that circle meets the criteria that it's exactly 5 units from the center of town. So they want us to label with an X all possible locations for the new park. So in other words, all possible locations that meet both the criteria on the locus that I sketched in pink pen and the locus that I sketched in the black pen. So there's one possible location. There's a second possible location. Part A, done. Now that I've taken care of Part A, I'm going to go ahead and worry about Part B. It says to the nearest tenth, what is the distance from the school to the new park? So in other words, they want us to calculate or compute this distance from one of the 2 schools to the park. Well, I know, and I can pick either one of my 2 schools. I know that my school A is located at 3, 3, and I know that my school B is located at 3, -5. So I'm going to go ahead and I'm going to use point A because it has coordinates that are positive. And I'm going to go from point A to that point right there. And the coordinates of that point right there are 5, -1. And I'm going to go ahead and use my distance formula. So distance is equal to the square root of the difference between the x values squared plus the difference between the y values squared. And then I'm just going to plug in. So 3 subtract 5, quantity squared. I've got my ghost coming in here again. I don't know why. 3 subtract -1, quantity squared. So when I plug that into my calculator tells me square root of 26. It wants me to round this to the nearest tenth. So I'm going to snag my calculator. To the nearest tenth, this distance is equal to 5.1 units. All right, now that said, I found the distance from the school to the closest park. I could have also found the distance from this park over here to the school. I'm going to say that when this question was written, they wanted the distance from the school to the closest park. But again, not really a terribly well written question because they weren't specific. They weren't clear about exactly which park they wanted you to find. All right, I'm going to jump up to the top of the next page and we'll take a look at the next example. This one says, on the set of axes below, graph the locus of points that are 4 units away from the point whose coordinates are 2, 1. Using the same set of axes, graph the locus of points that are 2 units away from the line whose equation is x equals 4. State the coordinates of all points that satisfy both conditions. I'm going to start by thinking small. I'm going to think about this in little baby steps, little baby pieces. And first of all, I'm going to address the first criteria. The locus of points that's exactly 4 units away from the point with coordinates 2, 1. So the first thing I'm going to do is I'm going to find the locus of points 4 units away from the point with coordinates 2, 1. So I'm going to grab my compass, and again, so that I can be as precise as possible, I'm going to use my compass to draw the circle. I guess I'll do this with my pink pen. So that pink circle represents the locus of points that's exactly 4 units away from the point 2, 1. Now, the second criteria that needs to be met in this problem is that we need the set of points 2 units away from the line whose equation is x equals 4. Well, the line whose equation is x equals 4 is going to pass through the x-axis where the x value is equal to 4. So I'm going to go find my x-axis, and along my x-axis, I'm going to figure out where x is equal to 4. And x is equal to 4 right there. So that's where my line is going to have to cross the x-axis. So there's my line whose equation is x equals 4. I want to find the set of points that are exactly 2 units away from that line. I'm going to go find some that are 2 units away. There's some that are 2 units away over here to the right, some that are 2 units away over here to the left. And so anybody that's 2 units to the right of that line is 2 units away, as is anybody that's 2 units to the left. So I can start to see that my locus is developing. It's going to end up being 2 lines, one on either side of x equals 4. So in response to the question, they want us to identify or state the coordinates of all points that satisfy both conditions. So there's one right there that satisfies both conditions. There's one up here that satisfies both conditions, and one down here that satisfies both conditions. So those coordinates, if I count them up, 6, 0, 0, 5, No, I'm sorry, not 0, 5, it's 2, 5. And then 2, negative 3. All right, the last one says determine the coordinates of the points in the plane that are equidistant from the 3 points 2, 5, to negative 1, and negative 2, 1. All right, so in keeping with the spirit of this, I'm going to go ahead and plot those 3 points. So A has coordinates 2, 5. There's point A. B has coordinates 2, negative 1. There's point B. C has coordinates negative 2, 1. There's point C. Now this question is kind of confusing because it really has 2 parts to it. It wants points that are equidistant from all 3 of those points. I'm going to think about this in 3 separate parts. I'm going to think about first the points that are equidistant from A and C. So that's where I'm going to go ahead and start. The points that are equidistant from points A and C is going to be the perpendicular bisector of line segment AC. So if I go ahead and draw line segment AC in there, from the graph I can tell the midpoint is right there. The slope of segment AC is positive 1, so the slope of its perpendicular bisector is going to have to be negative 1. I don't know why my computer is going crazy and drawing all sorts of random things on there. I must have been infected with some kind of ghost. It's October, Halloween, a month for ghosts, I guess. All right, so there's my perpendicular bisector of segment AC. The second thing I'm going to take a look at is all points that are equidistant from points B and C. That's going to be the perpendicular bisector of segment BC. So its midpoint is going to be right there at the origin. The slope of this guy is negative 1/2, so the slope of its perpendicular bisector is going to have to be positive 2. So anybody on that purple locus is going to be equidistant from points B and C. And then my last consideration that I have to take into account here is that I have to have points that are equidistant from points A and B. And again, I'm not quite sure how these purple dotted lines are getting on my paper. The ghost. So the locus of points that's equidistant from points A and B is going to be the perpendicular bisector of segment AB. So this one's a nice one to do because he's a perfectly vertical line segment, so I know his perpendicular is going to have to be perfectly horizontal and pass through his midpoint. So the points that are on all 3 loci that satisfy all 3 of those conditions, and there's only one, is that point right there. And the coordinates of that point are 1, 2. That is the point that's equidistant from each of those points. That last one I think is a tough one because there's actually 3 locus situations that you need to think about and consider. But if you take one step at a time, it becomes a lot more manageable than trying to do everything all at once. As always, if you have questions, jot them down in the margins or shoot me an email and we will talk about them the next time you come to class. And as always, thank you for the gift of your time. I hope that you found it a worthwhile investment and took something away from this video with you. And